Before we get into talking about functions, we actually need to define something called a relation. You see, a relation is a set of inputs and outputs that are related in some way. So if I had a column of x numbers like 1, 1, 2, 3, 3, 4, and I had a column of y numbers 2, 3, 4, 5, 6, 7, and I were to relate them in correspondence with each other such that 1 and 2 are an ordered pair, 1 and 3 are an ordered pair. Here are the ordered pairs down here, by the way. And here's 2 and 4 that's an ordered pair, and 3 and 5, 3, 6, and 4, 7. Then I would have a relation. Likewise, a relation can be represented on a coordinate plane, and here are the dots that represent the ordered pairs of the relation. And so here we are in our first math notes in this book, and it's based on something called functions. Functions now are defined this way. A relationship between inputs and outputs is a function if there is exactly one output for each input. That's an important thing to recognize because not all relationships are functions, but all functions are relationships. Functions are often written as y equals some expression involving x, where x is the input and y is the output. The following equation, table, and graph represent the same function. So here we got x is equal to 2, negative 1, 0, 1, 2, 3, 4, and 5, while y in correspondence are 16, 19, 4, 1, 0, 1, 4, 9. And so that's the graph of this relationship, or a function actually, called y equals quantity x minus 2 squared. Here's the graph of that right there. That's the way that the graph looks for y equals x minus 2 squared, and it's actually the shape of a parabola. The set of all possible input values for the function is called the domain. So all these numbers right here representing the input for x are the domain, while the set contains every x value for which the function is defined. The domain of the function above is all real numbers. I also like to say the domain is everything that x can be. The range of the function is the set of possible output values. This set contains every y value that the function can generate. As the graph shows, the minimum value for the function occurs at the vertex where y is equal to 0. So the range of the function above is y is greater than or equal to 0. And another way that I like to say range is that the range is everything that y can be. Another way to write a function is with the notation f of x. This is called functional notation. So f of x equals, instead of writing y equals. The function named f has the output f of x, and the input is x. So we show this with a little function flow here. If we said that x was equal to 5, and we stuck it into f of x is equal to x minus 2 squared, then we could take 5 and subtract 2, that's 3, and then square 3, and we end up with an f of 5 then is equal to 9. And that's how we end up evaluating a function of f of x. If we're saying f of 5, I say that that's equal to 9 because the input is 5 and the output is 9. X squared plus y squared equals 1 is not a function because there are two y values, which are outputs, for the same x values as shown below. So notice what we have here. X now is negative 1, 0, 0, and 1. We have actually values of y is equal to 0, negative 1, 1, and 0. And if you plug in those values for x and y here, you'll see that you end up with these points that fit on this circle. This circle then is not a function. It is a relation between these ordered pairs, but it is not a function. Now, one of the things that we're going to be asking you to do is to actually do a problem called 1-3. 1-3 has these four functions, and they draw a nice function machine around the function, but really the way that I really want you to look at these things is that this first one is just simply f of x is equal to the square root of x, and that g of x is equal to negative quantity x minus 2 squared. And that this next one is going to be h of x is equal to 2 to the x minus 7. And k of x then is going to be negative x over 2 minus 1. If I wanted to evaluate, like if I wanted to say, what is g of 3? Well, then you'd say g of 3 means I'm looking at this g of x function, negative, parentheses, 3 minus 2 squared. And as we evaluate this now, we say negative, 3 minus 2 is 1, and squared. Well, 1 squared is 1, but that negative is still out in front. So g of 3 then evaluates to be negative 1. Let's do another one. What if I wanted to know what the f of 16 was? Well, f of 16 is actually saying what is the square root of that x value, which is 16. Well, square root of 16, you know that to be 4. But I want you to be aware of something here, and we will emphasize this every once in a while. When we're taking the square root of a number, I want you to also be aware that this is asking the question, what number times itself gives me the number inside the house? Well, what number times itself is 4, because 4 times 4 is 16. That the answer could also be negative 4. And so I want you to be aware of that and make sure that you're able to answer the question appropriately. So now that we know how to evaluate functions, what if we were to do something like stack multiple functions in such a way that when we start with a certain number with one function and then take the output from that function and put it in as the input of the next function, can we get some predicted results? Well, I know that a certain order of these functions will work in such a way that if I stick in a 4 at the first one and I get a negative 5 out of the last one, that'll work. And so let's see if I can come up with it. Let's start off with, how about like k of 4. So k of 4 is going to be negative 4 over 2 minus 1. Well, that gives me negative 4 over 2 is negative 2, and that minus 1 is negative 3. Well, so I'm going to take that negative 3 now, and I'm going to go, let's see, which one works here? How about g of x? Let's go g of negative 3. G of negative 3 is going to be negative 3 minus 2, that squared. Well, negative 3 minus 2, we got to do that first, right? So it becomes negative 5, and we're squaring that, and we're putting a negative sign in front of it. Negative 5 squared, that's 25, and that's negative 25. Okay, negative 25. Hey, maybe we'll get it. Well, how about, we can't do f because we can't do square root of negative 25. So what of h of x? Well, okay, now we're getting kind of screwy. H of negative 25, and that's really saying 2 to the negative 25 power minus 7. Well, 2 to the negative 25, I'm going to need a calculator for that. 2 raised to the negative 25 power is some ugly number, and if I subtract 7, it doesn't make it any better. So I end up with something that looks like this. Negative 6.999 dot, 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 dot. So it's about negative 7. Well, that didn't work because now I'm not going to be able to do the f of negative 7 to get 5. So we should try that again, okay? So if we try that again, how about if we did something like, here, I'll change colors to show that I'm doing it again. And let's start off with maybe g. So we'll go g of 4. And that's going to be negative 4 minus 2 squared. Well, 4 minus 2 is 2, so that's really 2 squared. And so we have negative 4 because 2 squared is 4, right? And then we're going to say, let's see, what if I were to go with k? Well, I'm going to go k of negative 4 now, and that's going to be negative 4. It's going to look like this. Negative, you've got to put this negative 4 in parentheses because that goes over 2, and then we're going to subtract 1. So that's negative 4 over 2. Well, that's negative 2, but it's negative negative, so it's negative Negative makes 2 minus 1. That turns into 1. Okay, let's see. Next place to go? How about f of, we know what f of 1 is, right? Because the square root of 1 is 1. So we're just going to say f of 1. And that's going to be the square root of 1, which ends up being 1. H of 1 is going to be 2 raised to the 1 power minus 7. Well, that's 2 minus 7, and that's negative 5. We did it. We started with 4, ended up going G, K, F, and H, and got negative 5.